All right, we're off and running. Today's lesson is on obliques. That's the new word for today, oblique. And what does it mean? If you have an oblique asymptote, it means instead of a vertical line, it's going to be slanted. And don't you worry, I'm going to show you when that happens and all the good stuff. So first of all, we're going to fill out the top part. A little sentence framing. So when the degree of p at x, which is the numerator, so if we have p at x over q at x, when the degree of p of x is exactly 1 more than the degree of So let's write it down and make sure we talk about it to understand it. So when the degree of p at x is exactly 1 more than the degree of q at x, the graph will have a slant or a oblique asymptote. So when the top is more powerful, there is no horizontal asymptote. I should remind you of that, right? Some of you, like more than one person said, how does horizontal again? So if the top was more powerful, there was no horizontal. If the bottom was more powerful, it was 0. And if they were equally powerful, you divided, right, to find the number. Today we're going to look at the top is more powerful, but it's only more powerful by 1. That's a key thing. It's not just way more powerful. It's only power by how many? By 1. So when the degree on top is more powerful by 1, what type of asymptote are we going to look at? And it's called oblique because it's going to be a slanted line. So do you see the picture example on the right? Do you see the broken line? It's no longer that vertical, but now it's slanted. So we have a vertical, a slanted, but no what? No horizontal. Okay, so the equation of an oblique asymptote is y equals mx plus b, which is obviously a line. It is the quotient of p divided by q. What does that mean? Quotient means we're going to divide. Quotient is my answer. So when I divide top divided by bottom, do you remember how to divide polynomials? Do you know synthetic division and long division? We'll see. The remainder we can ignore. So what we're looking for is the answer without the remainder, and that will be a line. Because it's only 1 degree more on top, your answer is going to be a line in the form mx plus b. And so when we graph the oblique, we have to remember how to graph the line, mx plus b. All right. Step 1. We're going to now practice. It says using long or synthetic division, we need to divide, and then we're going to write the equation of the oblique. So first, before we start graphing, can you find and recognize that there is a slanted asymptote? So number 1. I'll start and then I'm going to ask to make sure you're listening. Number 1 is called a rational function because we have a polynomial divided by a polynomial. You with me? Good. Next, the numerator and the denominator. I'm looking at the power terms and I'm looking at the degree. What's the degree of the numerator? What's the degree of the denominator? Is the degree of the numerator 1 larger? Therefore, this has an oblique asymptote. Now the question is, how do I find that slanted line? And the answer is we're going to divide. Now, the divisor is the denominator. Is the divisor a simple linear? Yes. When I say simple linear, it means that a is 1, right? Or m is 1, and we just have a number adding or subtracting, right? The reason I ask it is, could I use synthetic division to do the dividing if it's x plus 4? Good. So what's the 0 of x plus 4? And then how do I write the coefficients inside here? How many x squares? How many x's? And the constant. Now I know you remember this. So we're going to, 1 plus nothing is 1. Negative 4 times 1. Negative 1 and negative 4 is negative 5. And this will be tough for you. The remainder, I'm just going to put an x there just to remind myself that that's not what I need. So this remainder, the reason we want to know if the remainder is 0 is to know if it's a factor, right? To know and terms of finding the zeros. We're not doing that work. We're just finding the oblique asymptote. So the oblique asymptote would be y equals what number in front of x? What's the slope? 1x, and then the y-intercept, or the b, and you just found the oblique asymptote. So before we start graphing, we need to know how to find it. All right, let's look at number 2. So first, how do I know this is a rational function? We have a polynomial divided by a polynomial. How do I know there's an oblique? Different than the other days. What's the degree on top? What's the degree on the bottom? Is it 1 bigger on top? Good. How do I find the oblique? Is divide. Is the denominator a simple linear? So I can use synthetic division. What's the 0 of the denominator? All right, can you fill in and then divide and then find the oblique asymptote? And I'm purposely putting an x where the remainder is so I don't get fooled by that number because it has no consequence to the slanted asymptote. So what's the slope of my line? 3 and the y-intercept. Number 3. Now it's my turn to ask. Chris, how do you know this is Smith? How do you know this is a rational? So it's a rational because the numerator and denominator are both polynomials. So how do I know it's a rational? Are polynomials. How do I know there's a slanted asymptote defined? One more question, and then I'm going to pick on somebody else. How do I find the oblique asymptote? By dividing. And is it a simple linear on the bottom? So I have to use long division. So let me set this up. And let's see if we can remember how to do it. All right, Daniela. And at any time you forget, it's because you're human, you could just ask, right? And I'll help you. So how do I find the first term using long division? What do I do?
You divide the 3x by 6x squared.
Right, the other way around, right? 6x squared divided by 3x, right? What do you get when you divide that? Good. So 6 divided by 3 is 2. And when you divide x squared and x, you're left with x. What would you do next, Daniela?
I will multiply 2x plus 2.
So, well, 2x times 3x, they have to match. And then 2x times, which is? What's the remainder?
0.
Excellent. Now, the number I'm going to bring down is negative 11, right? Now, the thing is, my remainder is less powerful than my divisor. So dividing here, right, is not going to give me more. It's that negative 11 is just my remainder. See, what's left over is weaker than the divisor. So there's nothing left to do. Now, we remember to write the remainder like this, correct? But for the oblique, the remainder is not what I'm looking for. So what was the quotient without the remainder? So our oblique is just what? You guys are good. Knock. Are you with me? Knock on your desk if you're with me. Knock on it. Right? We're with it this morning. Are you happy it's Friday morning? You going to sleep in till 1 in the afternoon tomorrow? Oh, man. Man, when I was a teenager. Never mind. 4. The good old days. No 2-year-olds running in your room at 5:45 in the morning. Here we go. 4. You ready, Miss Kimberly? Well, I haven't even asked my question yet. How do you know this is irrational? I'm listening. This is a rational function because we have a polynomial divided by a polynomial, the numerator and denominator. So, Kimberly, why is this a rational function? We're going a polynomial divided by a, that is what a rational is. A poly divided by a poly. Okay. Can you tell me why there's an oblique asymptote?
Because the degree is one more than the degree on top.
Yeah, the degree on top is one bigger, right? And then the big question, how do I find the oblique? What do I mathematically have to do? Good. Is the denominator a simple linear? So what must I do to find the oblique? So I'm going to put down, now there might be a missing term here. Do you see any missing powers? So I might need 0x and I might need 0. And I'm going to divide until I get to the remainder, and then that will be the answer. All right, Evelyn, how do I start dividing here?
You divide x cubed with x squared.
What answer do you get?
X.
Okay, you're starting perfect. Nothing wrong at all. Keep going.
And then you multiply x and then x squared.
And you get?
X cubed.
Keep going. You got to distribute to every term. So all three terms get times x. So the next would be?
4x.
Well, x times 2x is?
All 2.
2x squared. And then x times negative 3 is?
Negative 3x.
Now, we got to be careful here when we subtract. But I know you'll be careful. Can you tell me what's left over?
X.
Can you see?
Yeah.
Okay, so tell me.
3 minus 2 is
Is 1. I got that. 1 what?
x squared.
Yeah, right? They're x squares, right? So when you subtract, you're left with 1x squared. How about the next one? How many x's do I have?
Negative 3x. Oh, plus 3x.
You sure, right? You catch that? So when you subtract a negative, and then I don't believe I'm going to need the 0, but it's there. One more time, Evelyn. What do I do next?
You divide x squared with x squared.
And what do you get?
1.
Excellent. Now, I'm going to save you the pain. What the subtracting here, I don't care. Once the remainder is weaker than the divisor. So how do I know I stop? When the remainder is weaker than the divisor. Do you know what I mean by the word weaker mathematically? The exponent is smaller. Yes? So I'm stopping. Do I need to really write down the remainder? No. I have what I need. So what's the answer? The oblique is y equals x plus 1. Some of you, when looking at the quiz, I didn't punish you, but you're getting sloppy in terms of how you write things mathematically. Is the line x plus 1 or y equals x plus 1? Is a horizontal asymptote 0 or y equals 0? Is the vertical asymptote negative 1 or x equals negative 1? Get what I'm saying? So I didn't punish you that you just put down a number, but we need to write it properly going forward. Yay? Okay, turn the page. Yes. We get to graph. And I get to ask you. You ready? All right, Rosie, you ready? How did yesterday's game go? So on YouTube. Tell you what happened.
We were
Won. Like easily? Who lost? Right? Down they went. Awesome. Did varsity win?
Yeah.
Nice. Are we like number 1 in DBL? Volleyball?
One varsity.
No, you guys are JV. So what are you? Number 1 in DBL, right? Let the big girls be the big girls. No, I heard they're all tied, right? All right, forever on YouTube. My prediction is we're going to win DVL. See? It's now like solid, right? Can't dispute that I predicted the future. Here we go, number 5. Dalia. I'd like to know I gave your big brother a big hard time yesterday, right? That he doesn't always support you on your math and waits for you to ask him. And I said, that's awful. And they all were hard on Jesus yesterday. Let the world know that Jesus should take initiative to help his baby sister out and say, hey, how's math going? Is there anything I can help you with, right? There we go. It's now forever, right here. Going to be uploaded today. All 300 people will listen to it. So, let's start. Valia, why is this irrational? I'm going to help you through the steps. Is that okay? Step 1 is to factor. I want you to look at the numerator and believe in yourself that you can factor it. Tell me what the factors are. Step 2 is, what's the domain? Where do I look? What can x not be? Nope. Yes. I'm not going to worry about the range. Is there anything that's removable? Good. It is what it is. That means there's no... Cross it out. X-Intercepts. Where do I look for the X-Intercepts, Dahlia? Yeah, tell me the 2 numbers that make the top 0. What are they?
-3 and
Do you know what the multiplicity is of both? Yeah, confidently, right? You don't see the one. Why does that matter? Because it tells you the behavior at the intercept. It tells you if it crosses over or just touches. So you know why it's important. All right, we're going to continue. Marilyn, how do I find the Y-intercept? What answer do you get? I want to hear Marilyn. It's undefined, which means, right? No Y-intercept. Now you're going to say, why is there no Y-intercept? Well, let's keep going. What's the vertical asymptote, Marilyn? Where do I look for the vertical asymptote? In the denominator and the domain restriction, right? Because they go together. Since there's no hole, guess where the vertical asymptote is? 0. Marilyn, keep going. Is there a horizontal asymptote here? No, why not? Because the numerator is more powerful, isn't it? The degree on top is bigger than the degree on the bottom. You listening? So why is there no horizontal? Because the top is more powerful. Not. But instead of a horizontal, guess what we have? Right. And how do I find the oblique? What do I have to do? Divide. Now, I know it's tough here. You ready? You can use synthetic. It feels awkward. Do you know what number I would use? Is the 0 of the bottom, or the 0 of that, which we just said was what? So guess what we're going to divide by? And now, don't look at the factored form, but look at what the expanded was. How many x squares? And missing power? And -9. What does that look like when we divide? Oh, go ahead. So how do I divide this? So bring it down. And then I don't care. So can you tell me now what the answer is when I divide? What does the 1 represent? X. And the 0 is the Y-intercept, so it's just Y equals S. So SA, I'm going to put in the word oblique because it's a new, SA is slanted asymptote. But we're learning a new word, oblique. So it's Y equals X is the oblique. Awesome. We're ready to graph. Thank you, Marilyn. All right, who's going to help me graph? Davian, can you help me graph this? Do you like graphing? Is it something that you feel confident in?
Yeah.
Excellent. It's all that, right? And once you feel good about graphing, something you like it. Because it's kind of fun to be able to see a representation, a picture, all kinds of stuff going on. Tell me how I should start my graph, Davian.
Start by graphing the x-intercepts.
What are they? All right, can I do that? Positive 3 and negative 3. Keep going. What else can I put on my graph? Where's that? Well, it's at 0, right? And a vertical line that goes over 0 looks just like that. What else do I put on my graph? This one's brand new, but I believe in you. What else am I going to put on my graph? Yes. Do you know how to graph the line y equals x? Or would you like support? So y equals x is in the form mx plus b, which I always think there's 3 things people remember in math and never forget. Y equals mx plus b, right? A squared plus b squared equals c squared. And then sometimes they remember the volume of a box being length times width times height, right? And then everything else is like, I don't remember anything else. So, you remember y equals mx plus b. I don't see a number at the end, but these numbers here also tell you how to graph it. So the y-intercept's at 0, and the slope is 1. So can you start at 0, and then what do? Go up 1 and to the right 1, and there you go. Some of you, I know, love rulers. If you love a ruler, there's rulers in the blue box near the door. I had a ruler at one time. Who knows where my ruler even went? Oh, I found it. So, if you need a ruler, because you know you're wibbly wobbly when you draw a line with 2 points, right? Or, I see that too, you have an ID around your neck. Apparently the ID card is like the perfect length for that. Now, some of you also do this on your quizzes. You ready? You don't draw broken lines. Do you not like the word broken because it makes you sad in the heart? Dashed lines. Not broken, but dashed. Does that make you feel better? Like it's Santa Claus and reindeer? So it makes you feel warm inside about Dasher? But I just don't want you to draw a solid line. Can you not do that for me? No solid lines for asymptotes. Yes? No solid lines for asymptotes. So I'm going to connect these 2 points. But when I connect these 2 points, what type of line am I going to use? A dashed line. I know, broken feels sad inside. So, dash. It's also, isn't that the name of the sun in The Incredibles? Right? Dash. So that makes you feel warm inside too. So, dash. I'll use it. All right. Davian, how do we feel so far? Good. Now, how many vertical asymptotes do we have? And the reason I ask that, there's one, it splits it into 2 pictures. If you had 2 vertical asymptotes, you'd actually have a right, a middle, and a left, and so on. So we actually have 2 curves. But the good news is, I have 1 point on the right and 1 point on the left. I actually don't need more points to find, because I have a point on each side. But what I need to know is, where do the arrows go? What's the end behavior, and what happens at the vertical asymptote? So I'm going to start easy. At the vertical asymptote, there's only 2 options. It's either going to go up forever or down forever. I want you to look at this point on the right. What direction do you think it's going to go? Is it going to go up forever, or is it going to go down forever? And one of the indicators is, likely it's not going to cross over the oblique. So if it's not going to cross the oblique, what direction is it going to go? Down. Good job. Now, the other one's going to be a little bit more challenging. Do you remember that the horizontal asymptote was the end behavior? Like one end went down or up forever, and the other end followed the horizontal, yes? Yeah. But we don't have a horizontal. Instead, we have an oblique. So the other end is going to follow the what? So one end goes up or down forever at the vertical asymptote, and the other one follows the oblique at the end. Can we follow the same thing here? By the way, our vertical asymptote is odd. Why does that matter? Because one end goes down then and one end goes up. And if we follow this, what's going to happen to the left? Where's the oblique to the left? One end goes up forever and the other end's going to follow the oblique. So one follows the vertical and the other follows the oblique. And that's it. If I asked you what the end behavior is, The right end behavior, the right end, is going up. It's going to infinity. The left end behavior is going to negative infinity, and in the middle it does what it does. But end behavior follows the oblique. The same end behavior as y equals x. All right, number 6. Yay! We're with me? Yes. Love it. John Gruden would be so happy. Number 6. Whoever John Gruden is. Jocelyn, are you ready? Man, you have raised your game. I'm proud of you. Number 6. Step number 1. I'm sorry.
You don't factor that?
Yeah, step number 1 is definitely the factor.
Okay,
And so then the question is, how do I factor the numerator? And it might be that you need a moment to think about it. The first thing I look at, is there anything they all have in common to factor out first? First, I look at that.
No.
The answer is no, right? Now I go, oh no. It's going to take like 2-3 steps, right?
Mm-hmm.
Are you willing to do the 3 steps?
Yeah.
Let's go. So what do I do first?
Multiply negative 20 times 2.
What is that number? Negative 20 times 2 is negative.
40.
What do I put underneath?
Negative 3.
Take a moment. What 2 numbers match to factor?
Can you help me?
Yeah. Think of 2 numbers that multiply to 40. So it's not 4 times 10. But I'm going to tell you the 2 numbers are less than 10. Like they both are small numbers. You just have to think of. What is it?
8 times 5.
Good. So it's negative 8 and
Positive 5.
positive 5. Now, are you going to make the mistake and say, oh, it's x subtract 8 and x plus 5?
No, you have to plug it back into the equation.
So instead of negative 3x, I'm going to plug in negative 8 and
Positive 5.
positive 5. All right, what do I do next, Jocelyn?
Factor by grouping.
So if I group the first 2,
You pull out a 2x.
so I factor out a 2x, what's left?
X minus 4.
Good, next.
And then you factor out a 5.
And what's left?
X minus 4.
Now it's getting easy. See, each step gets easier. And how I know is they match, don't they? So I'm going to go back to the function, and now I can write down, what are the 2 factors, Jocelyn, on top?
2x plus 5 and x minus 4.
Excellent. That was the hard work. You did it easy. Good job. All right, let's keep going. Who's going to help me? Eduardo. What do I do next? Step 1 was to factor, and that took like a minute. Now what? Excellent. What's the domain restriction? And what is it in this equation? Excellent. I'm not going to worry about the range. X-Intercept. Eduardo, where do I look? So what are the 2 zeros at the top? And what's the other one? And they both are odd. Why does that matter? No, these are X-intercepts. So why does it matter that there's an odd multiplicity? So what you described was an odd vertical asymptote, right? It's going to cross over. Exactly. Y-intercept. Thomas. How did you guys do yesterday?
Great.
Did you guys win? Nice. What was the score?
30-0.
What? Domination. Y-intercept. Are you ready? Did you get hit hard? Or can you, like, think through this? Okay, how do you find the Y-intercept? And what answer do you get? So, wherever there's an X, you plug in 0. What's left on top? Negative 20. Yes? And what's left on the bottom? So, negative 20 divided by 1 is? Excellent. Thomas, where do I look for the vertical asymptote? Where do I look? Amelia. You look in the denominator. What makes 0 in the bottom? And it comes also from your domain restriction. So negative 1. Why, Thomas, is there no horizontal asymptote?
Oh my goodness. I swear.
I'll help you. There's no horizontal asymptote because the numerator is more powerful. Thomas, why are there no holes?
Oh, because there's no matching.
Nothing matching, nothing removable, right? You did great. Are you awake for me this morning? You knocking, right? We're good? All right, Genesis is going to take over. Genesis, how do I find the oblique? That's the new word for today. How do I find the oblique? Can I do synthetic or not?
Yeah.
Excellent. So how do I set it up? So the 0 of the divisor, -1, and then what goes inside? All right, go for it. No, but talk to me as you're doing it. You said bring down the 2?
Yeah.
Next?
-2, -5, 5.
And here's the thing, right? I don't care, right? So the remainder doesn't affect the oblique. So what's the answer for the oblique? 2 what? 2x subtract 5. Do you see mx plus b? Your m is 2 and your b is -5. So we're going to write down y equals 2x subtract 5. Now we're ready to graph. All right, Diana, you ready? Here we go. How do you feel about graphing? Feel confident? Okay, how do I start? What are they? I don't know how to plot -5/2. Is it -2.5? I can find that. So -2.5. That's not -2.5. How about this one? -2.5. I'll use my little whatever here. What's the other one? Like it never happened. The other one's what? 4. 1, 2, 3, 4. I got it. Now, what else could I plot or try? Do you see -20? It's not on my graph, so I'm not going to sweat it. We're just going to let it go, right? What else could I put on my graph? Where's that at? All right, let's make sure I'm paying attention. That's -1. There's no horizontal, so what's the oblique? So how do I graph that? Do you remember how to graph a line? Where do I start? So I start the Y-intercept, which is -5. The slope is up 2 and to the right 1. All right, I'm going to take out my ruler. Am I going to draw a solid line? What word are we using to describe the line?
Solid.
Not solid like a rock, but dash, right?
Dash.
Like little Dash that runs really fast? Like Dasher who brings you presents? Here we go. Okay, we got to finish this. So Dan, look. Do you know where the ends are going to go here? So first of all, do you see the vertical asymptote? I'm not going to cross over the oblique, okay? So instead, I'm going to follow it, and then what's going to happen is the left end's going to go down forever following the vertical. Do you know where the other end's going to go? It is going to follow the... So one end is going to follow, and there is a little curve there, but it's hard to see. But can you see one end follows the oblique, and the other end follows the vertical? How about on the other side? One end is going to follow the vertical, and the other end follows the oblique. And these are curved. They're very vertical how they curve, but they're still curves. But can you see where the ends are going?
Yes.
As we describe it. We got 2 more like this. Then the learning happens when you do your homework. So, number 7. Caitlin. We ready? Tell me step 1. How do I factor 6x squared plus 11x, take away 10? I got to hear you. What did you say? So you telling me there's no common factors? So to factor this, I'm going to go 6 times negative 10, which is negative 60 and 11. Go for it, Kaylin. What are the two numbers that fit? I love it. That's why we don't give up, right? 15 and negative 4. So then I'm going to do a substitution. So the substitution is take out the 11x and put in 15 and negative 4. Do you know that what you don't practice, you eventually forget, right? So that's good that we get to practice this and not ignore it, because eventually we'll forget if we don't practice it. Kaylin, what do I do next? And what's left over? And then the next one? Excellent. What's left? Man, you made that look so easy. So when I look at the numerator now, what are the two factors in the numerator? Excellent. And then we have a 2x subtract 1, right? That's not easy, right? You got to practice, right, to get that right? Cristobal, what do I do next? Let's do it. What's the domain restriction here? So do you know where you're looking? Do you know where you're looking? The bottom, right? What makes the bottom 0? What's the 0 of the bottom? You add 1 and divide by, right? What is it? It's 1/2, right? The range we're not going to worry about right now. X-Intercept. Cristobal, how do I find the X-Intercept? The numerator. What are the, do you see the factors in the numerator? Each factor has a 0. What's the 0 for 3x subtract 2? And it's odd, means it's going to cross. What's the factor for 2x plus 1? Or 2x plus 5? That's 2x plus 5. What's the 0? Over 2. Good. And it's odd. That matters because they're going to cross over there, right? All right, let's keep going. Michael, what's the Y-intercept? How do I find it? You were daydreaming. No. So wherever there's an x, you plug in 0. A 0 is like an eraser. So if I plug 0 on top, I'm just left with negative 10. If I plug 0 on the bottom, I'm left with negative 1. And that's all you do is divide. Negative 10 divided by negative 1. What do you get? Perfect. One more time, Michael. Now you're awake. Vertical asymptote. Where do I look? Top or bottom? The bottom. It tells you what the bottom is 0. It's also in the domain restriction. Where is the vertical asymptote? Excellent. Why is there no horizontal asymptote? The top is more powerful. Yeah. Why is there no holes? There's nothing removable, right? We're not going to use SA. Instead, we're going to use the word oblique. Lizbeth, how do I find the oblique asymptote? So I can't use synthetic in this case because it's not a simple linear. So I'll set it up for you. Then you tell me what I do to find the first term of my line. And what do you get? Okay, keep going. Can you distribute the 3x? I'm just going to stop and make sure Thomas is doing what I'm doing. Thomas, what are you doing on your phone there? Are you like have Desmos and you're double checking to make sure we're doing it right? You want to see your graphing calculator? Or something else completely? Something else, okay. We're going to do math together? Okay, cool. So 3x times, you said it was 6x squared. How about 3x times negative 1? And then I'm going to subtract, and of course when you subtract you're careful because the signs are tricky.
So if you distribute the negative to both points, you would get the 6x cancels out and you would get 14.
Excellent. One more time.
Bring down negative 1.
What do I do to get the last one?
Divide 14x by 2x,
What do you get?
7. And then it would be 14x minus 7.
Now, I don't care about the remainder. So what I do care about is what's the oblique now? Y equals what? Excellent. We're ready to graph. Melissa, are you ready to support me on graphing? Awesome. Where do I start?
You can start by graphing the X-Intercept.
So the X-Intercept's at 2/3. I don't know exactly, but can I estimate it? Where's the other one?
2 and 5.
What is it?
5 halves.
So what is negative 5 halves?
It's 2.
Yeah, so negative 2.5. Thank you. Is there a Y-intercept?
Yes.
I don't know if it counts. Can we see if it counts to 10? I don't know.
No, it doesn't.
It does not, so I'll just ignore it for now. Where's the vertical asymptote? Now, be careful here. You ready? Is 1/2, because you got to know your fractions, should 1/2 be to the left or right of 2/3?
To the left.
Yes. So, because if we don't do that, the graph's not going to be correct if we don't understand that point is actually to the left. We have one more. Where's the other asymptote? Yes, we do. Right there. I'll circle it.
Oh, yeah.
Yeah. That's the whole point of the lesson, right? Yeah. What is it? Yeah. The word of the day. So 3x plus 7. Do you know how to graph that?
Yeah.
Where do I start?
7.
So I'm going to count 1, 2, 3, 4, 5, 6, 7. Then what do I do?
And then you go 3.
And what do I do?
You go to 3.
So,
7.
do you know what you want to do is go up 3 and over 1, but it's off my graph. So I'm going to give you a hint. You know what we can do instead of going up 3 and to the right 1? We can do the exact opposite. What's the exact opposite to up 3 and over 1? Down 3 and to the left 1. Let's try it. So I'm going to go down 3 and to the left 1. Again, I'm going to go down, how many? 3 and to the left 1. Down 3 and to the left 1. You know what I'm worried about? Is this point right there. Is it on the left or is it on the right when I draw that line, right? If I got to be like so accurate. Wait, this is wrong right here. Down 3 and to the left 1. I'm going to draw a line. If you're super accurate, what do you notice about that X-intercept? Is it to the left or to the right of the oblique? Now we're going to finish off the graph. On one end it follows the vertical, and on the other end it's going to curve and follow the oblique. It's going to follow the oblique, and on the other end it's going to follow the vertical asymptote. I guess. All right, one more. Number 8. Aaliyah, what do I do first?
Factor.
Can you factor the top for me?
Yeah, you just take factor and x.
And what are you left with?
X squared plus 3x subtracted.
Can you factor the denominator for me?
X subtract 2 x plus 2 subtract 2.
So plus 2 and subtract 1. Now, when I look at the numerator, does it factor further? So what's left in the parentheses? Could you keep factoring? What two numbers factor the numerator? You did an awesome job. So confident and perfect. And we didn't have to draw a diamond or anything crazy, right? To do that? One more step, Aaliyah. Is there something removable here? So what do we have in this function is a whole. And at what x value do we have the whole? What's the 0 of what I crossed out? 1. All right. Now, it's going to be helpful to have x plus 4 over x plus 2. It's also going to be helpful to distribute the top so I can divide. So if I distributed the top, Aaliyah, what do I get? If I take the x and distribute, if I get rid of the parentheses on top, what do I get? So both are going to be helpful. I need both. So why do I need one? Why do I need the other? Pedro, what's my domain restriction?
Domain x, 1 and -2.
Good. Do you notice that I crossed out 1, but that's still a part of the domain restriction? So it's -2 and 1. Do you know what the X-intercepts are, Pedro?
The X-intercepts are -4
Yes?
and 0.
And they both are
Odd.
odd. Notice that's for factoring, right?
Yeah.
For the Y-intercept, go to the other one. If you put in 0 for x, you get 4 divided by 2, which is?
X -2.
No, put in 0 for x. So 0 and 0, I'm left with 4 divided by 2, which is 2. What's the vertical asymptote?
-2.
And it's odd.
Yeah.
Why is there no horizontal asymptote?
Because the power term,
It's more powerful on top. How do I find the oblique?
the oblique, we divide.
Okay, Rosie?
So does that have to be a 4x?
Did I go x squared and 4x? Is you right? Rosie, thank you. So what does that affect then? It's not going to be 2. Instead, it's 0 and 0 divided by 2, which is what? 0. Thank you for saving me. All right, so the word for today is oblique. Pedro, how do I find the oblique?
We divide.
Can I use synthetic?
No.
Yes.
Oh, no, yeah. I'll look at the...
That's okay. So simple linear, what's the 0 is -2. What did I put inside?
You put 1, 4, and 0.
Okay, divide.
That goes to -2. And that equals 2.
Now, I don't care about the remainder, so what does this give me?
Y equals x plus 2.
Excellent. Let's graph this. Jessica, you ready to graph this? You can put on the sweater because it's cold. It's fine. It's like 75 out. Yes.
Do you find the whole yet or not yet?
Oh, we didn't find the x value of the whole. Pedro, finish that. How would I find the x value of the whole? What would I do? Plug in what number for x?
1,
So what would the top be if you plugged in 1?
5,
And what would the bottom be?
3.
Excellent. So it's 5/3?
Yeah.
Thank you. All right, Jessica, how would I start this graph?
Plot the x-intercept.
What are they?
-4 and 0.
So 1, 2, 3, -4, and the other one is
0.
0.
The y-intercept is 0, so it's already there.
Already there. What else can I put on my graph?
The vertical asymptote,
Where's that?
2. -2.
So at -2. What else can I put on my graph?
The oblique,
How do I graph this?
you go up 2,
So I start at 2 on the y-intercept, and then?
go up then right one.
So up 1 to the right one. And then I'm going to take out a ruler. I need to make sure I'm accurate as best I can. Dash.
You need that's the whole.
And we still have to graph the hole. Where's the hole located?
1 and 5/3.
Are you comfortable about where 5/3 is on your graph? Tell me. Let me be comfortable. 5/3. Where do I put that on my graph?
About 1.6.
What? That's pretty cool, right? Like 3 goes into 5 once, right? And what's left over is 2, right? And you knew that's 1.6 repeating? That's crazy. So 1, between 1 and 2, right? So between 1 and 2, approximate it. Can you see where the hole is? You have such good number sense. All right, let's finish this. So we have points on both sides of the vertical asymptote. So we can just go to the graphing. So Jessica, what's the behavior on the left? What's the curve going to go to?
Going down.
So on the left part of it's going to the vertical asymptote, and then it's going to hop over the hole and follow the oblique. So we're going to curve, hop over the hole, and follow the oblique. How about on the left? What's the curve going to look like?
It's going the
So it's going to follow the vertical there, and then as it goes to the left, it's going to follow the oblique. Awesome. You know that we just did what was today's lesson on? Oblique. Do you know a rational means you're dividing two polynomials? Do you know that there's an oblique when the top is one more powerful? And to find the oblique, we divide. Synthetic or long division? Rock stars. That's it. The lesson's over. Mr. G Math. Out.